Hello, my name is Owen Gibson, and this is my tutorial 10. I'm sharing my screen now, so this is the first task. We've got a simple system with a unity feedback gain. We need to derive the root locus and the value of k for a 5% overshoot, and then the natural frequency with that value of k. This is my solution. That's a quick diagram. So the first thing we do is find the poles. That's just done using the quadratic equation. And then we need to put k into the system in open loop. You know that for a 5% overshoot, zeta 0.69, we can equate that to 0.707 to get a 45-degree angle. And here's the desired pole location here. So at negative 1.5 and 1.5, negative 1.5, negative 1.5. And we can work out the angle breaking off there at 270 degrees. And then we can calculate sigma here. To get our desired poles. There are two methods to find k. The first one, the one I prefer, is finding the product for the finite pole lengths and the finite zero lengths, and doing about you get the answer of 2. To find c in closed loop, you use the closed loop negative feedback equation. You get the transfer function here, and then we know that zeta 0.707. And using the equation 2 zeta omega n equals 3 for S value, we can find the frequency there. And the next part of the task is looking at a much more complicated system and using the root locus techniques again and the steady state error. So very similar to last time, you find the poles and the zeros, and then you can then draw the root locus like this. Difficulty is finding the breakaway point. I use this equation, which is the sum of 1 over sigma plus zeta is equal to 1 over the sum of 1 over sigma plus poles, not zeta, pardon, the zeros. And then you're able to find the breakaway, these points at negative 29.5 and negative 0.49. And using the k equation I used earlier, I calculate k to be 58.2. So inserting that point of 29.5 and 58.02, you can find the error is negligible, effectively 0, using the step input equation. And you can then find the damping ratio using the negative feedback equation. You calculate for 2z omega n is 59, and then you know and what omega n is, because omega n squared is 870, and then you can then calculate zeta to be 1. Thank you.